Now let us review those viscoelastic properties. And viscoelasticity just means that tissue have some properties that are elastic like a rubber band and other properties that are more fluid-like, so they exhibit that viscosity. There are four main viscoelastic properties. Creep. If I impart a constant force, so we keep the force constant, over time, that length of that tissue will gradually increase. And we can take advantage of this property during a low load stretch. The second property is stress relaxation. So now we lengthen the tissue to a specific length, and now the force needed to maintain that specific length is going to decrease over time. And you can feel this during manual stretching when you stretch a tissue to a specific length. The amount of force needed to hold it there, that's going to go down over time. Hysteresis, this just means that when you lengthen and relax a tissue, the load deformation curve is not going to follow that same path. And the difference between that is going to be the heat released or the energy that is lost during that loading and unloading. So this is why a dynamic stretch heats up tissue, because some of that energy is lost as heat when you lengthen a tissue and release it. So that heat builds up in the tissue itself. Strain rate sensitivity, our final property. Tissue behaves differently if you load it rapidly versus slowly. When you rapidly load tissue, it is stiffer. When you load it more slowly, it is less stiff. And that is functionally important because when I'm moving slowly, I don't want to impart as much stress on my tissue. So it's good that that stiffness is going to be decreased when I'm moving slowly. But when I need to impart forces quickly, so I need to jump, I need to sprint, those tissues are stiffer, which allows me to impart those forces into the ground more rapidly and allow me to be more efficient with the running or that jumping.